Yay! We're getting closer to done. So I must confide in you, nice people, that I have now taken off another piece of clothing during the recording of these videos, and I'll give you a hint. You can decide which piece of clothing it is. The hint is it's 2 feet. The mind wanders. Anyway, what we're going to talk about in this edition of Plan Cash Liars is when loop joins, when loops are not quite living or not quite giving you the information that you need about them. So I've got the reason that this is a parameter related plan cache liar is because the number of loops that you have to do depends on the number of rows, and of course SQL Server, if you have enough rows coming back, will probably not choose a loop join. However, in the case of parameter sensitivity, parameter sniffing, we might have a query like this that runs very quickly. My gosh, that's fast. If we look at the query plan, this took just about 22 milliseconds to run. Right? Impressive. Yeah? Good. 22 milliseconds. You were fast. And keep in mind these numbers down here. 518, 391 to 518. That's okay. We've still managed to do well here, down to where we got 10 of 10 for our top 10 right there. Yeah. Look at that. That's nice. That's a good plan. When we run it for parent ID equals 0, it is an ungood plan. This is the saved version of the plan that I've got, where this takes 2 minutes and 28 seconds to run in its entirety. Some stuff to keep in mind here. Looking at this plan, we had a whole bunch of nice, tiny, narrow little lines where nested loops made sense. Over here, we have, again, big, thick lines with nested loops. Again, not scientific, but usually a pretty good indicator that maybe we made a bad choice. And the operator costs are all inherited from the previously compiled plan. The cost of 0%, the estimate of 518 rows, which turns out to be drastically wrong across this entire thing, at least until we get to 10 of 10 over here, which that's great. But what we see in the actual plan is things like the number of executions here, right? You can see we did a lot of those, right? And that should match the number that we see there. On this inner side of nested loops, we'll see another really high number of executions. But this stuff is all missing from the estimated plans because the cache plans, because the cache plans will only give us, or rather I should clear that out. They should only give us these lines, right? Say we estimated 517.998 executions. That was dismally, dreadfully wrong, wasn't it? That was not anywhere near reality. If we look at the cache plan, of course, we're going to come upon a couple frustrating things. One, again, the very low cost. Two, if we go over here, I only have the plan in cache this time around for the small one. But if we look at, that's the only one that's in cache because that's the one I ran. The other plan would reuse this plan. The other query would reuse this plan like we just saw. But what we would see in the plan cache is, just the crappy little tiny little arrows. We would see the estimated number of executions. And it might be difficult to figure out why this is slow, especially because when SQL Server caches a plan like this, well, the execution parameters that get cached along with it are for the first execution. Now, something that I added to Blitz Cache a while back was getting cached execution parameters from the plan XML. This can get a little bit faulty, especially if you're declaring variables in the plan inside of a store procedure or something. Then I can't get those for some reason. They don't show up in the same way. The other thing that can be a little odd is if you have multiples of the same plan in cache, you'll see duplicate parameters. I stuck that in there because I thought it might be helpful for parameter sniffing, stuff like that. But if we go look at what SQL Server, how we executed that query, we will see that this first parameter. Why this is unhelpful is because when we have that, all we're able to generate is this fast plan. I can run this 1,000,000 times, 1,000,000 times, and it will always be fast. Always. It will never be slow. Sad, right? And the cache plan will never give us any more detail. However, if we get very lucky and we find the parameter that causes things to really fly off the hinges, we're only lucky if we run this query first, right? Because like if we clear out the proc, if we free the proc cache, and we just look at an estimated plan for this, we'll see that this query plan looks a little bit different, right? We go parallel, at least in the estimated plan. Well, I don't know if this will happen in real life. Who knows? But now this one runs quickly. And if we look at the execution plan for it, you can see why. Right? We went parallel. Things got sorted around a little bit. There are some differences between this and well, I should just have that open. All right. Differences between these two plans. Look where that sort operator is. We do the sort really early on over here. In this plan, we do the sort at the end. There's just a whole lot of stuff that ends up differently so that we need to process way more rows throughout all of this plan, whereas in this plan, we process a lot of rows early on, weed those out, and then go about our work. And we have a fairly quick plan. What sucks here is that if we look in the plan cache now, right, for this iteration, for just parent ID 0, we'll see a higher cost, of course. We went parallel and all that stuff. And if we go over here, we'll see that we use a little extra CPU to we used extra CPU in order to reduce wall clock time, right? We went parallel, but the cached execution parameters here will just be for 0. If we run this with the 0 plan, this will be quick too. So really, the only way that this gives up the ghost completely, or in a meaningful way, is if we get this parameter, run it, cache the plan for this, and then run it for parent ID 0. So this is why parameter sniffing is so tough, is because not only do you need the parameter to like get the good plan for a parameter, then you need the parameter that when it reuses that plan, things go to hell, and then you need to run them in the right order to reproduce it. So this is why parameter sniffing is one of the very, very tough things, and this is why one of those reasons why I'm like, maybe recompile isn't the worst thing in the world. Like maybe it's not your enemy. Maybe we should have a second look at recompile. Anyway, that's it for this video. In the next video, we will talk about spills. Ooh, spills, chills, thrills. I'm almost 40, so I need to write a will. Sad. Anyway, I will see you in the next video. Thanks for watching.